Alright, let's look at the homework 7, problem number 8. Alright, so we have a triangle ABC with the magnitude norm of vector AB is equal to the norm of vector AC. So which means that these are isosceles triangles. So AB and AC congruent. So you have isosceles triangle. So M is the midpoint of the base BC. And use vector to prove that the vector AM, so AM is this guy right here, right? And the other vector is BC, so vector BC would be right here. So this is the vector BC, right? So I guess for simplicity, I'm going to use this notation. I'm going to call vector AB vector V. How about that? Right, so this is same thing as vector AB, and vector AC, I'm gonna call it the vector W. Right, so this is vector AC. Right, so we know that the magnitude of vector V is equal to magnitude of vector W. Right, so the norms are the same. Alright, then let's rewrite, let's see, we're looking at the AM, right? So AM, how would you write AM? Right? So in order to go from A to M, you can actually go down forward on V, then you can do halfway on vector BC, right? And actually, I want to know what the BC looks like. So I'm going to do BC first. Alright, so BC, vector BC is equal to, right? You can just, let's see, from B to C, you can go backward on vector V, which means that the negative vector V. And then you can go forward on vector W. So we have that. Right, if you want, you can write it as vector W minus vector V. I think it looks cleaner this way. Right, so AM is going to be, you can see that you can go forward on V, so I'm going to have V here. Then you can go halfway on BC, vector BC, right? But you can see that the vector BC is the same thing as this vector, so you can actually plug this guy in here, right? So which you get, this is going to be V plus 1/2 vector W minus vector V. Alright, so this is going to be V here, and a negative 1/2 V, so it's going to be positive 1/2. So if you simplify this, you're going to get this 1/2 vector V plus vector W. Actually, maybe I'll keep the same. How about this? Vector W plus vector V. Right? So you get that. So all you have to do to establish the perpendicularity, you need to show that vector AM dot product with vector BC is equal to 0. Right? So you can use this guy. So this is vector BC right there, and here this guy is vector AM. Right? So use the property to show that, work it out, and make sure to show that this is actually equal to 0. If you can do that, then you can say therefore. So you have to fill in the gap here, right? Then you can show that since dot product is equal to 0, these two vectors must be perpendicular to each other. Alright, that's it. I hope that this will get you guys going.